Hi everyone. In this video, I'll be explaining my banking system OOP challenge that I have built in Dart, which demonstrates all four pillars of OOP: encapsulation, inheritance, polymorphism, and abstraction. This project stimulates a real-world banking system with different account types: savings, checkings, and premium. Each account type has its own rules like minimum balance, withdrawal limits, or interest rate. The design shows how OOP makes the system modular, reusable, and easy to extend. So now let's get to the first pillar of OOP, which is encapsulation. Encapsulation is about protecting data and controlling access. I made the account number, holder name, and balance private using underscores. You can see here int underscore account number, which had made the account number private. This prevents direct access from outside the class and ensures the data safety. After that, I then used getters and setters to allow controlled access, for example, to validate deposits or withdrawals before changing the balance. So you can see here I have used getters and setters. Uh, where Now let's talk about inheritance, one of the most important pillars of OOP. Inheritance basically allows us to build a new class based on existing one. In this project, I have created a base class called bank account, which defines the common features that every account type must have. Things like account number, holder name, balance, and methods for withdrawal and deposit. But in a real banking system, not every account works exactly the same way. A saving account, for example, has restriction on withdrawals and minimum balance requirement. A checking account might allow overdraft but charge a fee. And a premium account is usually designed for high value customers with extra benefits like higher interest rates and unlimited withdrawals. Instead of rewriting all the logic from scratch for each account type, we simply let them inherit from the base bank account class and then customize only the parts that are different. Let's start with the savings account class. This one inherits all the core features from bank account but adds a few specific rules. It enforces a minimum balance of $500. It limits withdrawals to 3 transactions per month, and it provides a 2% annual interest rate through the interest bearing interface. So, if a user tries to withdraw too much or make more than 3 withdrawals, the system will block it automatically. This behavior is unique to saving accounts, but everything else, like deposits, balance tracking, and displaying info, comes directly from the parent bank account class. This is perfect example of inheritance. We reuse existing functionality and just extend it to suit the needs of a specific account type. In the same way, I have created the similar logic with checking account and premium account. So the third pillar is polymorphism, which basically means many forms. It allows the same method name to behave differently depending on which object is calling it. In my project, every account type, savings, checking, and premium has its own version of withdraw and deposit methods. So when I call withdraw on savings account, it checks for the withdrawal limit and minimum balance. Here you can see in savings account there is different withdraw and uh, different withdraw and interest bearing section here. When I call it on checking account, it allows overdraft but applies a fee. And when I call it on premium account, it simply processes it without limits. So here you can see there is no any limits on this withdraw, and uh, and that automatically figures out which withdraw method to run. That's runtime polymorphism in action, one common interface and multiple behaviors. This makes The code's super flexible. If I ever add a new account type, like a business account, I don't have to change the logic in my bank class. It will automatically work with the new type as long as it implements those same methods. Finally, let's talk about abstraction, the fourth pillar of OOP. Abstraction means showing only the essential features and hiding the complex details. In this project, I have demonstrated abstraction using the abstract class bank account. This defines what every account must have, like deposit, withdraw, and display info, but it does not define exactly how these actions are done. Each subclass like saving account or checking account implements its own version of these methods based on its own rules. So when you check into the saving accounts, how withdrawal is done, you can see here. And in the same way in checking account, the method is different, right? I also created an interface called interest bearing, which defines a method called apply interest. Any account that earns interest, such as savings or premium, implements this interface and provides its own logic for interest calculation. So you can see I have a different section abstract class which is interest bearing, which calculates interest, and it has been implemented on savings account and premium account. So this way I can call apply interest on any account without knowing its internal logic. That's the power of abstraction. It hides unnecessary complexity from the user and ensures that every account type for. So that's my complete banking system project built in Dart. Uh, Now let's see it and run it. So here in the console you can see uh, I have created three accounts, one for each saving account, checking account, and premium account. So there is a withdraw method called for all these three accounts. So in case of there is no any account, you can see here it prints account not found. So according to the OOP challenge, I have also created a bank account reports where it shows the display info of each accounts, the account number, holder name, balance, account number, holder name, balance, account number, holder name, balance, and interest bearing accounts with their interest. You can see here. So where I have demonstrated all four pillars of OOP, which are encapsulation, inheritance, polymorphism, and abstraction. Throughout this project, I tried to make it feel as close as possible to a real world banking environment. Each account type, savings, savings, premium, behaves differently but still shares a common structure from the base bank account class. So overall, this project helped me understand how OOP makes complex systems like banking more organized, scalable, and secure. And thank you for watching my project demonstration.